Hello everyone and welcome to another video. In today's video we are going to be looking at how we can find equations of tangent lines using the rules that we have learned in the previous video. Okay, so we are going to start by recalling that the derivative of a function of f of x at x is equal to a, we use the notation f prime of a, represents the slope of the tangent to the graph at the point P, which is given by the coordinates of a, comma, f of a. Okay, so we are going to remember that the derivative represents the slope of the tangent line to the graph at a specific point. All right, so keeping this in mind, let's take a look at our first example here. Example 1. Let's find the equation of the tangent line to the function f of x is equal to 1 over the square root of x at x is equal to 4. And we want to express the answer in both standard and in y is equal to mx plus b form. So this is also going to be a little bit of a review of lines, of equations of lines. Okay? So let's do this. In the previous video, we looked at how we can take the derivative of different polynomial functions. So that's basically a function that is composed of terms to different powers, right? And really, this is exactly what we have here. All right, we are going to start by rewriting the function that we have, right? We are given f of x is equal to 1 over the square root of x, but in order to use the rules that we have learned in the previous video, we have to rewrite this. And so we know that we can rewrite a square root as an exponent, 1 over 2, and we know that we can rewrite fractions or a reciprocal function using negative exponents. So really 1 over the square root of x can be rewritten as x to the power of negative 1 over 2. So now that we have the function in this format, we can just simply use the power rule in order to take the derivative of this function. So again, recalling the power rule, we are going to take the exponent as a coefficient, right? That's going to be our new leading coefficient. We are going to keep the variable, which is just x, and now we are going to subtract 1 from the previous exponent, right? So we're going to have negative 1 over 2 minus 1, which is really the same as having minus 2 over 2, okay? Because we have negative 1 over 2 minus 2 over 2. So that's going to be equal to negative 3 over 2. All right, and now we can just take the extra step and we can rewrite the function to have it in the format that we were given. So this is the same as having 2 times the square root of x to the power of 3. But now we want to find the slope at a specific point. This is the general derivative of the function that we were given. This is the general derivative of f of x, but we want to find the slope at a specific point. So we want to find the derivative when x is equal to 4. So let's plug in x is equal to 4. So we want to find f prime at 4, which is going to be equal to negative 1 over 2, the square root of 4 to the power of 3. Okay, so it's going to be equal to negative 1 over 2. 2 times the square root of 4 is just simply 2, which is going to be equal to negative 1 over 2 times 8, which then, of course, is just equal to negative 1 over 16. So now we have our slope, right? Negative 1 over 16. This is our slope, m. So in the form y is equal to mx plus b, we have our slope. Okay, so in the form y is equal to mx plus b, We don't have y here yet, but we can definitely find it, right? So if we have that x is equal to 4, then f at 4 is going to be equal to 1 over the square root of 4, which is going to be equal to 1 over 2. So this is going to be our value of y. So here we are going to have 1/2 is equal to negative 1 over 16 times 4 plus b. This is one way in which we can find the equation of a line, right? Just plugging in the values that we were given. Alternatively, we could also use the method y minus y1 is equal to mx minus x1, and then from there we would get the value of b as well after we expand and simplify. So it is totally up to you which method you would like to use. But going back to our previous method here, we are going to have 1/2 is equal to negative 1 over 16 times 4. So we're going to have 1/2 is equal to negative 4 over 16 plus b. Negative 4 over 16 is going to simplify to negative 1 over 4 plus b. And now we can just simply add 1/2 to 1/4 to get b. And we are going to have that b is equal to 3 over 4. Putting all of this together then, we have that y is equal to negative 1 over 16x plus 3 over 4. And this is going to be our final equation of the line. Now, this is the equation of the tangent line in the form y is equal to mx plus b, right? But we were also asked to find the equation of the tangent line in standard form. Okay, so remembering that standard form, this means that we want to have the equation of the line as ax plus by is equal to c. So basically all we have to do, we are just going to multiply through by the greatest common factor, and we are going to rewrite our expression. So what I'm going to do is that I'm going to take the y is equal to mx plus b form, I'm going to multiply it through by 16, right? Because I want to cancel out that denominator. And this is going to result in 16y is equal to negative x plus 12. And now the last step is simply to just rewrite it so that we have x and y on the left-hand side and then the constant on the right-hand side. So rewriting is going to give us x plus 16y is equal to 12. And this is the equation of the tangent line in standard form. And this is our first example. So again, the process is the same as we have seen before. We find the derivative in order to find the slope. And then once we have the slope, we use that to find the equation of the tangent line. Okay. Let's take a look at another example here, example 2. Find the equation of the tangent to f of x is equal to x squared plus 6x plus 9, which has a slope of 6. So this question is slightly different, okay? So we're going to be going through a slightly different process because we are given the original function and now we are given the slope, okay? So this is a piece of information that we didn't have with the previous question, right? We know that f prime of x is equal to 6. So in the previous question, we were given a point right? And we wanted to find the equation of the tangent line at that point. In this question, we are given a function and we are given the slope. So we need to find out at which point does the function have a tangent with a slope of 6. Okay, so we know what the slope is, but now we need to find what the derivative is, because we want to find for which values of x in the derivative does the function or does the derivative equal to 6. In other words, right, if the derivative of the function is given by, or if the function is given by x squared plus 6x plus 9, then the derivative f prime of x, here again we're just going to use a mix of the power rule, the constant rule, and the sum rule, right? So I'm going to take the derivative of each of these terms separately or independently. So what is the derivative of x squared? The derivative of x squared is 2x. What is the derivative of 6x? It is just 6. And what is the derivative of 9? The derivative of 9 is just going to be 0. So our derivative here of the function f of x is equal to x squared plus 6x plus 9 is going to be equal to 2x plus 6. And now I want to find when is a derivative equal to 6. So putting those two together, right, forming an equation, I'm going to have 2x plus 6 is equal to 6. Well, that tells me that I have a slope of 6 when x is equal to 0. Okay, so that is going to be my point. If x is equal to 0, then f of 0 is going to be equal to 0 squared plus 6 times 0 plus 9, which is going to be equal to 9. So putting all of this together, the point 0.9 is on the line. And now I have the two things that I needed in order to find the equation of the tangent line. I have a point on the line and I have the slope of the line, right? Again, that is exactly what I need for the form y is equal to mx plus b. I need to have a point with coordinates x and y, and I need the slope, which now I have. So y is equal to mx plus b. Y is 9, m is 6, x is 0. So then, of course, b is just equal to 9, and I'm going to have the equation y is equal to 6x plus 9. And this is the equation of the tangent line in the y is equal to mx plus b form, or in the point-intercept form. In standard form, in this case, I don't have any fractions. All I have to do is to, again, rewrite this equation so that x and y are on the left-hand side and the constant is on the right-hand side. Doing just that, I am going to have negative 6x plus y is equal to 9. And this is the equation of the tangent line in standard form. Okay, so just a slightly different example, a slightly different look at the kinds of questions that you might come across. Another example, another style of question would be something along this line. At what point or points does the curve y is equal to negative 1/3 x cubed plus 3/2x squared have a tangent line with slope negative 4? And then we want to sketch the graph and the tangent lines. So here again, we are given some information that we should not overlook, that we cannot overlook. So here again, we have that the slope or the derivative, right, is going to be equal to -4 at a certain point. And so those are the points that we want to find, right? But in order to do that, first we need to know what the derivative is. So starting with our function here, y is equal to -1/3 x cubed plus 3/2 x squared. Let's take the derivative. Okay, y prime. Again, I'm going to be using a combination of the coefficient rule, the power rule, and the sum rule. So here I'm just going to leave the coefficient alone, -1/3. I'm going to multiply it by the exponent, right? I'm going to bring this exponent now as a coefficient. So times 3. I leave the variable as it is, and then I subtract 1 from the original exponent to give me a power of 2 in this first term. Okay. Then for the second term, 3/2, right there, I'm going to leave that coefficient. I'm going to multiply it by the exponent of 2, which is now going to become a coefficient. I leave the variable alone, and then I'm going to subtract 1 from that original power to get a power of 1. Now I just simplify. Y prime, -1/3 times 3, that's just -1, so -x squared, and then 3/2 times 2 times x to the power of 1, well, that is just simply equal to 3x. So the derivative is given by -x squared plus 3x. And so now, again, I have a value for the derivative, which is equal to -4. So once again, putting these two pieces of information together, I want to know for which values of x is -x squared plus 3x equal to -4. Rewriting this as a quadratic equation, I'm going to have -x squared plus 3x plus 4 is equal to 0, which I can factor as -x plus 1 times x minus 4. There we go, is equal to 0. So here I end up with factors. X is equal to -1 and x is equal to 4. So I have two values of x at which the tangent would have a slope of -4. So let's find the equations of these tangent lines, all right, for both of these values. So right here, for x is equal to -1, here again, I'm going to have a y value, plugging -1 into the original equation, -1/3 times -1 to the power of 3 plus 3/2 times -1 to the power of 2. And this is going to be equal to 11/6. So now plugging this into our formula, right? Y is equal to mx plus b. I'm going to have 11/6 is equal to -4 times -1 plus b. So here 11/6 is equal to 4 plus b, or rewriting this, b is equal to 11/6 minus 4, which is going to be equal to -13/6. So then we are going to have the equation y is equal to negative 4x minus 13 over 6. And this is going to be the first equation of the tangent line. And then for the second value of x, for x is equal to 4, the y value in this case is going to be given by negative 1 over 3, 4 to the power of 3, plus 3 over 2, 4 to the power of 2, which is equal to 8 over 3 after we simplify. And now again, we plug it in into our y is equal to mx plus b form. So 8 over 3 is equal to negative 4 times 4 plus b. Or, in other words, rewriting it, 8 over 3 is going to be equal to negative 16 plus b, or b is equal to 8 over 3 plus 16, which is equal to 56 over 3. So putting all of this together, y is equal to negative 4x plus 56 over 3. And these are going to be the two values, or the two equations, of the tangent lines with a slope of negative 4. So now let's graph this, let's sketch it. Of course, it's not going to be fully accurate, but let's try and keep it as neat as possible, right? So here we are going to have a cubic function, right? And we know that our cubic function is going to go through 0, 0, right? And if you want to, you can create a little table of values on the side just to guide your sketch. But some obvious values are that the function goes through 0, 0, and it will also go through the point 5, 3. So I'm just going to create a little bit of a scale here. 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. Here we go. 1, 2, 3, 4, 5. All right. We have a scale now. That again is going to guide our sketch. The function will also go through the point 5, 3. And then the points that we have are, of course, the points that we have found. Those are, of course, going to be points on the function as well. And we have the point negative 1, 11 over 6. So that's going to be negative 1, approximately 11 over 6. If we put it into a calculator, it's going to be 1.8, so close to 2, right? Negative 1, 2. So we're going to have a point that's going to be more or less around that area, close to 2. And then we are going to have the point 4, 8 over 3. Again, 8 over 3 is approximately equal to 2.6. So here we go, 4, and then around the 2.5 mark. Okay, so here we have a good guide of what the function is going to look like. So let's start sketching it. So here we are going to go up. Okay, and then we come down, we do a little swoop, we go up, and then we come back down. And of course, that is not perfect, but it's a pretty good sketch of what the function looks like, a general idea of what the function looks like, going through some points that we know are on the function, right? And then, so of course, our tangent lines then are going to be at those 2 points that we have just seen. And we know that they should be parallel because they have the same slope. And of course, in this drawing, they might not necessarily look like they're that parallel. I'm going to try my best to make them look parallel. But I do not make any promises. There's a reason why I became a math teacher and not an art teacher. But here we go. All right, and then our second one. There we go, right? So those are going to be the 2 tangent lines that have a slope of -4. So again, just another example of a type of question that you might see on an assignment or that you might see on a test that is related with finding the equation of a tangent line, okay, to a function. A final example would be a question such as this one. Tangent lines are drawn to the curve y is equal to -x squared minus 2 from the point 0, 2. Find the points at which the tangent lines touch the curve. Illustrate with a diagram. Okay, so again, some information is given to us, and we probably want to take a couple of seconds to really think about what we are being asked here, maybe even rereading the question, okay? So if we don't know immediately what we have to do, sometimes rereading the question can be really helpful. But here we have a function, -x squared minus 2, so we know that it's going to be an upside down parabola, right? And we know that we are going to be drawing tangent lines from a point that is above this parabola, right? So it's going to be, immediately we can add this to our diagram. If again we have that same scale, which works well. Okay, so we are going to be drawing tangent lines from the point 0, 2. So we're going to be drawing tangent lines from this point right here. And we have the parabola -x squared minus 2. So this is a parabola that has the vertex 0, -2, right? And that's going to be opening downwards. So we can also just draw this parabola so that we have an idea of what it looks like, what we're being asked to draw here. Okay, so now going the other way, there we go. All right, so basically, informally, what we are after is these tangent lines here. Okay, so here again, using my handy dandy ruler. Okay. I want to find the tangent lines that cross at the point 0, 2. Okay. So I'm basically looking for those 2 tangent lines. All right. So visually, these are the tangent lines that I'm after, but now how can I actually find them algebraically? All right, let's do that. We are given a function, y is equal to -x squared minus 2. And immediately with any question like this, right, we want to find the derivative. So y prime is going to be equal to -2x, okay? So a fairly simple derivative. Now, this is where we have to think a little theoretically, okay? Because we want to find the slope. We don't have a point, right? We don't have any points on the function, but we know that any slope that's tangent, or any line that's tangent to this function, is going to have a slope of negative 2x, right? So any slopes through the point x comma negative x squared minus 2, right? And the point 0, 2 are going to satisfy the condition that we want, right? Basically, we want to find the point for which this line will have a slope of negative 2x, okay? So we want to know what this point is, right? Which is going to be 2 different points, actually. And so we're going to keep the point in a general form, right? If we have a coordinate of x, well, we are going to have a y coordinate of negative x squared minus 2, because that is the function that we are given, right? And so this slope, if we use the slope formula of m is equal to y2 minus y1 over x2 minus x1, and we are going to let x be equal to x2 and negative x squared minus 2 be equal to y2, so that 0 is equal to x1 and 2 is equal to y1. There we go. So putting this all together, the slope is going to be given by negative x squared minus 2 minus 2, right? That's going to be our y2 over x minus 0. So here, simplifying, we have negative x squared minus 4 over x, or again, just factoring out a negative x squared plus 4 over x with that negative in front. All right, so this is what the slope, the formula for the slope would be, but we already know the value of the slope, right? The value of the slope needs to be equal to negative 2x, because these are going to be, it's going to be the slope of tangent to this function. So any tangent to this function is going to have a slope that's given by negative 2x, because that's the derivative of the function, right? So we note that. But the slope of the tangent to the curve at x comma negative x squared minus 2 is the derivative. Okay? It is the derivative of y is equal to negative x squared minus 2, which is negative 2x. Okay? So now, again, we have a way of setting up an equation, right? We have two values that are the same. This means that negative x squared plus 4 over x is equal to negative 2x. And now let's rewrite this so that we have x squared plus 4 is equal to 2x, canceling out both negative signs. Okay, is equal to 2x squared. There we go. So then we have x squared is equal to 4, or simply x is equal to positive or negative 2. So here again we have two different values for x. Well, when x is equal to 2, y is equal to negative 2 squared minus 2, which is going to be equal to negative 6. And then we are going to have slope m is equal to negative 2 times 2, because our slope is given by negative 2 times x. If x is equal to 2, then slope is equal to negative 2 times 2, which is equal to negative 4. So putting all of this into y is equal to mx plus b, we are going to have negative 6 is equal to negative 4 times 2 plus b, or negative 6 is equal to negative 8 plus b, which then gives us b is equal to 2. And putting it all together, y is equal to negative 4x plus 2, which is one of the equations to the tangent line. Okay. In particular, we know that we have a negative slope, so we know that it is going to be this line right here. That line is going to have equation y is equal to negative 4x plus 2. For the second value of x, x is equal to negative 2, well then y is equal to negative 2 squared minus 2, which is also going to be equal to negative 6. So we're going to have the same y value, which we can kind of see here from the graph, right? That the lines are going to touch the curve. Again, it's a parabola, so it's going to be, and it has not been shifted horizontally, so it's going to be symmetrical about the y-axis. And so it does make sense that we are going to have that slope on either side of the parabola at the same y value, right? However, the slope is now, of course, going to be positive, right? We are going to have negative 2 times negative 2, which is equal to 4, okay? So here the slope is going to be equal to 4. And we are then able to find our value of b by plugging it into y is equal to mx plus b, or again, negative 6 is equal to 4 times negative 2 plus b, and we are going to end up with that same equation. Negative 6 is equal to negative 8 plus b, so again, b is equal to 2, which also makes sense, right? Again, we know that because they both have the same y-intercept, and we already know what that y-intercept is, right? Really finding b here, I just wanted to show you that you do end up with the same value, but this work is a bit redundant because we already know what that y-intercept is. We are given that y-intercept, right? And then finally putting it all together, y is equal to 4x plus 2. And this is the second equation of the tangent line, or is the equation of the tangent of the other tangent line, which is the tangent line that we see here on the left. Y is equal to 4x plus 2. And so this is a great question because it really goes back to the definition of the derivative, okay? Going back to knowing that the derivative is a slope, okay? The derivative function is a collection of slopes at any given point of a function. And so being able to set up this work really here is key. And in order to be able to do that, we have to know that definition of the derivative and being able to use slopes and to use the formula for the slope in order to establish this connection, okay? So this is truly a great theory thinking based question. And with that, we come to the end of our video. I hope that you have found these examples to be helpful and that you are feeling better prepared for answering derivative questions. All right, with that, I hope that you have a great one, and I'll see you in the next video. Bye, everyone.